Everyone at home, welcome. We are going to look through your mole buffet lab today. So if you have this document out from Canvas, that would be really, really helpful. This video is going to allow you to see some data being collected. So the first thing we're going to do is head to station 1. And at station 1, we have a graduated cylinder, and I'm going to move down so you can see the graduated cylinder. Our goal is to record ourselves a volume. And let me just hold this up so that you might be able to see that at a better height. See if you can record the volume in that graduated cylinder. All right, moving on to station 2. Station 2 talks about glass, and we're told that glass is silicon dioxide, and we're trying to figure out how many atoms are in a piece of glass. So you might want to think your way through what sort of data you might need to answer that question. Here's our glass. If you want to pause the video and think to yourself, how am I going to figure out how many atoms are in this? What data do I need? Go ahead and pause the video. And if you've paused and come back, here's what I did. I weighed that piece of glass. And when I weigh said piece of glass, you can see that it has a mass of 4.422 grams. 4.422 grams. All right, let's jump on to station 3. Station 3 has Tums. Now these Tums are really, really old, so they probably give you more of a stomach ache than help. Here's my Tums. I'm going to throw this Tums on the balance as well. And when I do that, we get a mass of 1.308 grams. We'll call it 1.308 grams. Moving right along to station number 4. Station number 4 deals with some copper wire. And our copper wire looks like this. There it is. So we're going to throw our copper wire on the balance as well. I missed. Copper wire on the balance, it has a mass of 1.683 grams. 1.683 grams for the copper wire in station number 4. Moving on to station 5. Now station 5 has sodium chloride, so we've got this nice tub of sodium chloride down here. Additionally, we've got this little measuring cup, and one of the things on here is teaspoons. So in the interest of time, I'll just tell you that I did this one earlier. I filled up a teaspoon of salt, and when I weighed it on the balance, that salt had a mass of 8.846 grams. 8.846 grams. Moving on to station 6. Station 6 has this nice piece of gum. And in station 6 with the piece of gum, if you read your paper, it says that we need to calculate the number of sugar molecules that we consume when chewing. And so that's a little bit confusing what's going on. And so I want you again to think about how you might do that. So pause the video, think about how you might do that. All right, if you figured out your game plan, welcome back. Let me give you some information. This piece of gum, when it's unchewed like this, has a mass of 2.040 grams. 2.040 grams. Now I chewed a different piece of gum and I reweighed it, and whenever I chewed the gum, it had a new mass after it was chewed of 0.898 grams. So before it was chewed, 2.040. After it was chewed, 0.898 grams. Station number 7 has this nice piece of aluminum foil. And this piece of aluminum foil, we're trying to figure out how many atoms thick it is. So I've got some information to share with you that is important as we're figuring out how thick that is. Number 1, I can tell you as a reminder that volume is equal to length times width times height. So I measured my piece of aluminum foil with this ruler, and it turned out to be 7.50 centimeters by 7.50 centimeters. So it's a square, 7.50 centimeters on each side. I can tell you that I also weighed this thing, and it has a mass of 0.237 grams. 0.237 grams. Moving on to station 8, again, there's some thinking to be had here. So station 8 wants us to figure out how many atoms we use up, or how many atoms of oxygen there are whenever we write our name with that piece of chalk. And so if you want to think through, you can again pause, think through how you might do that. How might you figure out how many oxygen atoms are in that piece of chalk? And so once you pause the video and come back, I can tell you that this chalk, I tried it, it weighs 4.664 grams, 4.664. I then wrote my name on the chalkboard, and it has a new mass of 4.139. So before I wrote 4.664, after I wrote 4.139 grams. Station 9 has some interesting stuff going on. So we've got ourselves a candle. And our candle is right here. We're going to figure out what sort of mass this thing has. So when I throw this on the balance, you'll notice that my candle has a mass of 81.697 grams. 81.697 grams. Now I'm going to go ahead and light a match. So I'll let you guys sit tight for a second. And we are going to light a match. I'm going to let this burn for a little while, and we're going to come back to it. All right, so my candle is lit. Let's come back and let's see what that mass looks like a little bit later on. While we wait for station 9 to go ahead and burn, we're going to move on to station 10. Station 10 has a nice cardboard box. My cardboard box here is filled with air. I want to know how much air is in this cardboard box, so I figured out its volume using this meter stick. I can tell you the dimensions that I found. So this box has dimensions of 46.21 centimeters by 29.73 centimeters by 23.11 centimeters. So again, those dimensions, 46.21 by 29.73 by 23.11, and they are all in centimeters. Station 11, we've got some aspirin. And when I take the aspirin, I'm going to throw this thing on the balance as well. And you'll notice that when we put the aspirin on the balance, we get a mass of 0.364 grams. 0.364 grams for the aspirin. And finally, station 12 is a little bit strange. Station 12 is this fun little jar, and this jar has some information written on it. Now, the information written on this jar, it tells you this, but that is the mass of the jar when it's empty. So that jar when it's empty weighed 94.404 grams. But then I took the empty jar, again it weighs 94.404 grams, and I filled it up with a substance. You can see the substance in there. And I can tell you that I put in exactly 0.050 moles of whatever substance that is. So that was the mass when it was empty. I put in 0.050 moles, and now this jar has a mass of 97.388 grams. So you'll notice 94 written on the jar, that's the empty mass. It now weighs 97.38, we'll call it 388 grams. So you guys can calculate the difference. All right, that's station 12. Let's find our way back to station 9 where our candle has been burning. And if I look at it, our candle now has a mass, let's cut the timer right now, it now has a mass of 533 grams. 81.533 grams. And again, that mass that's leaving, we're burning away wax, we're doing combustion, so we've got a hydrocarbon turning into carbon dioxide and water. So hopefully you guys can utilize this data to complete the write-up for your mole buffet lab.